Assalamu alaikum wa rahmatullah, and good afternoon for all of you. Inshallah, today we are going to continue our database design. So last week's actually we started the stages of the designing databases, and we learned many steps, many things. So for today we are going to continue the database design. Learning the normalization process. Okay, let's go and take a very fast cab about what we have learned in this stage, or for this topic, for the database design. We have learned how to describe the database design phases. Why? Because we learned what is the phases and what's the design life cycle and so on. After that, we learn how to explain or how to construct the entity relationship diagram using the Chin model or the Cruise-Fort model to design relationship diagram. Then after that, last week we learned how to transform the entity relationship diagram into real tables and relations. Okay. For today, we are going to start and learn the normalization. So how to use the normalization to decompose a relation with anomalies into well-structured relationship. Okay. So from here, from this point, we could understand that this normalization actually is used to what they call it, to optimize or to tune up the structure of our design. So after we draw the entity relationship diagram and after we do the transformation into relations, then maybe we can detect some anomalies. So the anomalies actually the things that is some things that we shouldn't have in our design. Later we will know what kind of anomalies do we have to avoid. So these anomalies, to avoid them, we have to go through some steps of normalization. So in every stage, we will get rid of some anomalies. Okay. Before we start this new topic, actually we are going to go back to the assignment that I gave last week, and we try to solve it together. But let me first modify this, because I want to stop the submission. Okay, because it a kind of I don't want to help you or something like that, but really it's very necessary to be honest with each other. That's why I have to close it in order to avoid a new submission after we discuss the answer here together. Okay. So today already disabled. Okay, good. Regarding the assignment, the assignment actually is very simple. That's why I'm not going to give much marks about it. It's a little bit portion of marks I will give. So this is the assignment. The assignment is very simple. Nobody. Is it very hard? Moderate. Okay, what's hard in it? Actually, we talk many scenarios more difficult than this. So we suppose not to have any issue with it, right? Okay, anyway, I'm going to draw the things here on the screen so everybody can capture, after we finish, can capture screen and compare it to your own. Then what I want you to do, I want you to mark your design. 10 marks. Okay, 10 marks actually is maybe 1% of your total marks. Don't worry about it. I make it 10 to make it easy for you to mark. Okay, so everybody, I want you to find your mistakes to honestly mark to yourself. Then after you give a mark, I will collect the marks from you. I will draw it on your paper. Then I will mark myself. I compare with your marks. I will see. If I find very far, I mean, that our marks are totally different, then we may need to discuss. Okay, because I want you also to be able to understand where is your mistakes. Okay, so for now, what do we have here in this slide? We have two entities and one initiative entity. Why initiative entity? Because this one actually has what they call it attribute, and the attribute cannot be attached directly to the to what they call it relation unless this relation is an associative. Associative relation means it's a relation through a table. So that means the table has some attributes, and this table is to form many-to-many. Is that clear? So here of the student table, it's supposed to be like this. What do we have here? We have SSN, which is the student number. I don't know why they make it SSN, but anyway, SSN it's understood, it's a metric number. Then we have the name, measure, and address. Name, then measure, and address. Okay, so here, based on the information in the diagram here, they did not mention that the SSN is a primary key, but based on the available attributes here, the only unique attribute is the SSN, right? Because we cannot have two students or more than one student with the same metric number. So that's why this SSN is going to be the primary key. Okay. Let us go and see the course. Course has ID, name, and credit. So we are going to draw here ID, name, and credit. Credit like this or wrong? Credit. Okay. So this one is the courses. As I mentioned, tables must be always in plural. This one's supposed to be students. And then here at the middle, we have to have a relation. This relation actually, before the relation, we forgot to mention about the primary key, the primary key of the class, of the course. So the ID is the primary key because the name of the course is not necessarily to be unique because sometimes the name, the course that was or that have been or that had been offered for a long time, then after that it may be deactivated, then after that they wanted to change it or offer it again with different ID. So in this case, the name will not be unique. Okay, so to avoid any duplication in names, or the case of having more than one course with the same name, in this case, we have to rely on the ID, which is the course code. Okay, here based on this diagram, what do we have at the middle? We have the relation which is takes. Okay, takes here is to attach courses to students. So when the students want to add some courses in his account or in his portal, then the course ID should be taken from the course table, and the student ID should be also taken from the student table, then supposed to be saved in the, what they call it, maybe registration. Registration. Don't forget this, registrations, or course registration, or maybe student course. It's up to you. Okay, so in this case here, we have to have SSM, and we have to have the course ID, because here the course ID, we must write something to mention that this is a course ID. So the name of the column is supposed to be descriptive. I write here CID, I supposed to write course ID completely, course ID, because names must be descriptive. In this case, we wrote only ID because the ID here is the ID of the course table. It's very clear. We shouldn't repeat the table name inside the column. So in here, it's a bad practice if you use the name, instead of name here, you write course name. It's a very bad practice. This will make your life miserable when you do coding later. All your field names will be very long, then your commands will be very long. Also, you need to remember the spellings and everything. That will make it hard for yourself. Okay, so instead of using the table name inside the column name here, we use only the pure or the absolute column name. Instead here in the other table, which is an associative table or associative relation, here, because this ID is not belongs to the registration table, then we have to mention this one is coming from where. This one is very clear. No need to write students SSM because SSM is only for students. But for ID, we cannot use ID only because ID could be course ID, could be staff ID, could be whatever. That's why here we need to write course ID in a complete manner. But for the purpose of designing on the screen, it's very hard for me to write the full name. That's why I wrote it shortly like that, CID. Okay. Here also we have in the diagram, we have date. So this date is the date of registration. Date of registration. Okay, date. Okay, so here, this one actually is a foreign key from here. So this side is 1, this side is many, right? This side is many. Okay, before we continue, let us take some information about the relation, because the cardinality of the relation must be written specifically and must be complete. Okay, so here, could we have a registration without student? Yes or no?
Oh, no.
No. So the student is mandatory, right? Student is mandatory. Okay. Could we have student without without registering courses?
No.
No, right?
No.
Yeah. Normally, when we register in a university, when we accept a student and we register his information on in our system, then after a while he will start and register his courses, right? So in this case, it's mandatory also, mandatory many. But in okay, let us think about it logically. So when we record, when you go to, for example, in UPM, at the beginning, when you go and register at the academic department, you fill up everything, you give them all the comments and everything, you make the medical checkup and so on. Then after that, they give you the matric number or they give you your registration slip, right? So after they give you your registration slip, you are already in the system saved, right? So you have one record, but yet you don't have any courses. Am I right? So we still have a gap between the creation of the student and the registration of courses. So that's why we could make it optional here. We could make it optional. Okay? Is that clear? But anyway, if you make it optional or mandatory, it's not going to affect anything actually. It's not going to affect anything. So it's up to you. If you want to make it optional based on the scenario that I explained, then okay. But if you think about it in total, so every student by the end of the day must have courses, more than one course. So it's mandatory to be mini, right? Also, this one is primary key, and this is a foreign key. So the mini is here, and the one is the other side of the course. We cannot have registration without course, so this one is mandatory. Also, every course we put in the system must have been registered by some students, right? Is it correct or not? Yes, right?
Yes.
So based on your opinion, it's mandatory, right? Mandatory mini.
Yes, yes.
But in reality, we have other case. The case of elective courses, maybe university or school could offer some elective courses that will never be chosen by anyone. So in this case, it will be optional, right? So some courses will be registered by students and some courses are not taken by students. So that's why we should make it optional in this case. Okay, so this is all about the design. We forget to have one more thing, which is the primary key of the registration table. So here, based on your opinion, what is the primary key of the registration table?
Registration number,
Student number.
registration number.
Where is the registration number? Is there any registration number here in this diagram? Is there a registration number here?
If I take one, cannot.
Okay, one thing. When what's this noise, guys? If you was given a design or entity relationship diagram, and your team manager asked you to, guys, please stop the noise. Stop the noise, please. Yes. Okay. If you was given this diagram from your, maybe from your boss, from your team leader, from your maybe senior, and the person asks you to convert this into relation, you shouldn't add anything. You must follow exactly what have been taken, what have been given in the diagram. You shouldn't add anything. Okay, so to follow this, we shouldn't have any registration ID, because here they did not mention if they need an ID for the registration. So in this case, they will make registration ID here on this diagram. So that's why we cannot add any other field. So what to do here is only to combine these two things together. Okay? To combine student with course ID. Do you agree with me? Okay. Is this okay? Is there any problem with this design? Could we think about it? Is there any possible problem could happen in future based on this design?
Doctor, I have a
Yes.
question. It's not a problem, but as what I did, I put the arrow, not the mandatory to one. The
Hmm.
so is it necessary to
We-
put? Is it wrong that I put arrow?
Actually, this thing is only for explanation here. It's only for explanation.
Oh,
But here you have to mention that this one is foreign key like this, and this one is foreign key like this. Otherwise, I will not understand that this is a foreign key. Anyway, I'm not going to cut any marks if you forget this one, because once you draw an arrow, that means you understand that this course ID is coming from the course table and the student ID is coming from student table. Okay, I will consider that. Don't worry about it. And now my concern, is it correct to make a composite primary key for the registration table, including the student ID and the course ID only? Could it make any problem in future?
I think no problem.
No problem.
I think no, doctor.
Okay, no one has any possible problem in mind.
I see that
Sorry? Anyone wants to give some idea?
don't have any course ID. How can I
No,
explain?
we cannot remove. The course ID is mandatory here in the primary key. We must put the student ID with the course ID. We must. But is this enough? The question, is this enough? Is it enough to protect our system from having any possible problem in future? This is the question here. So now we put these two as minimum fields for the primary key. Okay, I'm going to let you know what is the problem. The problem is that if let's say student number 100 takes the course number 200, then he failed. So he have to retake the course again, right? So in this case, he will have another record. So here we will have 100 and the course 200. At the semester, for example, first semester of 2020, okay, or 1920. Then let's say he failed. After that, he need to retake, right? 100, then 200. Then here the intake is different here, or the semester is different, maybe second 20. Okay, so here this value for the primary key actually is not unique. It's repeated. For some scenarios, it's going to be repeated, right? That's why we have to attach something that could differentiate between the repeated values. So in this case is the semester or the date. Okay? So date also supposed to be a part of the apart from of the primary key. So these three fields are together forming the primary key. Do you agree, guys?
Agree.
Okay. Anyone has an opposition?
Doctor, I have a question, but different from this. My question is, what if I use the ERG plus and then the table is different from your drawing? So is it correct or is it wrong?
What do you say? What if the ERD plus, what happened?
Okay, I use ERG plus table, so the table is different from your drawing. So is it wrong or it's okay?
You take my drawing and you draw again or modify, right? Is it?
No. What I mean is, my assignment, I use ERG plus, and the table is different from your drawing. So is it considered as correct? Because the table is like the chain models, right? So it's different from this diagram, the diagram that you draw. So is it correct?
Well, I couldn't understand. What do you mean? Do you mean that you did not draw this kind of tables or what? Or you mean you drawed using entity relationship diagram, entity relationship plus this one, right? So the shape is, you mean the design is different than my design, right?
Correct.
Yeah. So if you draw using here, using what they call it, entity relationship diagram, here you have to, you have not to select the, what they call it, chain model, or let it open first. I will tell you how to do. Why it's very slow. Oops. When you make a new diagram, you have this relational scheme. Did you?
Yes, I use the relational schema. Yes.
Okay, then it's very good. Yeah, it's more than clear. We have this one made like this, right?
Right. But if different
Yeah,
from your
it's very clear. Yeah, don't worry. I am going to consider this as correct. Don't worry. This one is an arrow. If you also draw by hand or you draw something similar to this and you don't put the cardinality, that's okay, because the cardinality actually is used with the entity relationship diagram. It's not used with the tables. When we design the tables, we not necessarily, we don't need to have this cardinality. We need to know how the fields are connected together. So we know based on this here, this is a primary key. So if there is a relation, the other part must be a foreign key. We don't have any other option. Okay?
Doctor,
Yes.
can I ask about the student tables? Since the name doesn't like have sub attributes, right? So if we put first name, last name, is it wrong?
If you put first name and last name only without name, that's okay. But if you write name, then first name and last name, that's wrong.
Okay.
Yeah. I'm not going to, I'm not here to cut your marks. You must understand this. I'm not here to cut your marks. I'm here to save your marks. I want you to success. I want you to understand, to get very good marks, because I want to be proud of you later. Understand this? So anything logical, I'm going to consider correct. Don't worry about anything. You just do your best to get the best design or good design. Then after that, leave it to me. Okay?
Okay, doctor.
Yes.
Okay, doctor.
One more thing that we would have actually, but not for our assignment, because as I mentioned, in our assignment we should exactly follow the diagram. Exactly. We should not write first name and last name unless we have them here. Maybe we have a direct entity a direct attribute connected to the student called first name, and another direct attribute also connected to the student called last name. Or maybe this name is composite, then it has two sub attributes, first name and last name. So in that, if this is the case, then we have to add the first name and last name. Okay, but for this diagram, we should write only name. But don't worry, if you write first name and last name, that's okay. I'm going to consider it correct. Okay, because this is not our big problem. You know, our big problem is how to establish correct relations, how to establish that there is no data repetition, there is no possible wrong scenario can happen because maybe we selected the wrong fields for our primary key, for example, for the registration, as the scenario I explained. So that is our concern. The normal attributes, actually, these attributes, like name, measure, address, this is whatever. You can put 1,000 fields. I don't care about them. I just care about the primary key and the foreign key in every table. Then here we have other fields like the registration. We have the result. We have maybe I don't know, maybe the result of the for example the semester what they call it. Oh, لا إله إلا الله. The semester work evaluation, the semester assessment may be field for the semester assessment, and also another field for the final exam. Then we could have also one option, one time, only one chance for repeating course. It depends on the system. If let's say the university has only one option, one time only as a chance to repeat a course, so maybe we include that in the same table. So we for example create here like first result 1 and result 2. Okay, so it could happen, but this is not a good design. Okay, so better design is to make the result here. Then this result could be, I mean, this course could be repeated or retaken twice or 3 times or more than that. And in every time, then we will have a result. For example, the first time is fail, maybe also the second time is fail. Then after that, maybe B, something like this. Okay? Here, yes.
What if I don't want to use the course ID and the date as primary key? I use SSM and I use registration ID. If let's say the question is not there, it's not the.
Yes. Okay. Okay. You want to use a registration ID for the registration table. Okay. When we have, if you go to our slide, to our slides, I explained this very well. Many times I repeated it. If the associative relation represents something that could stand alone, like an event, like for example, shipment. We have, for example, customer, item or product, and the customer make an order. Then based on the order, the items will be shipped to the customer. So in this case, we have something at the middle. called associative relation, which is the shipments, right? So in this case, the shipment actually is something in the reality. It's a something, it's a standalone something, right? That has an ID. But the registration is nothing in the reality. There is no registration ID. When you add course from the UPM system, when you add course, is it gives you any ID for your course? For your course registration? There is no ID, right?
Right.
Yeah, that's why we shouldn't make an ID. Okay, let us consider this. Let us remove this from here and consider that we create an registration ID here, registration ID, and we make this one primary key. Okay, so here, is there any constraint? Is there any constraint on courses? There is no constraints, right? So we can take the same course, we can register the course number 10, student number 10 with the course 200 at the first semester 20, and also we can register him again in the same semester twice for the same course. Why? Because this one may take like 32 and this one is maybe 52 or 55 or whatever. So here, this one is unique, right? But this one is wrong here. You see, this is a wrong scenario. We shouldn't allow this kind of scenario. That's why we shouldn't use this. We should use this because we don't want a student to register the same course twice in the same semester. You understand?
Yes.
Yeah. So if we don't use this and we make this 3 fields primary key and the same students wants to register the same course in the same semester for the second time, then the system automatically will raise an error. It's not going to accept it. Okay, so if we use this, if we use the registration ID, then we have to protect our system from allowing this kind of scenarios programmatically. So in this case, if you remember, if we do this wrong design, then what will happen? Our programmability, our programming need to be increased, right? So remember this. I just want to open the first slide that talks about the design. Okay, so if your design is poor, then you will rely more on the program. So you have to do a lot of tasks to protect this and to avoid that and to ensure this and blah blah blah, right? That's why design very well to minimize your programming. Okay, clear? Okay. Until now, is there any question? Anything not clear?
So far, no.
So far, no. Okay, then we are going to move to the normalization. I'm going to delete this. And we move to a new topic, which is the normalization. Okay, normalization, as I explained, is only to optimize or to make sure that your design is well structured. After you go through the first and second steps and you come with the real relation, then we have to check many things using the normalization tools. Okay, Before that, let us understand what is normalization. Normalization actually is primarily is a tool to validate and improve a logical design so that it satisfies criteria, certain constraints that avoid unnecessary duplication of data. So the most important concern for the normalization is to avoid the duplication of data. The duplication that's not necessary or unnecessary. Duplication of the value of primary key as a foreign key is not considered unnecessary. It's necessary duplication. Okay, as in our example here, for example, the car report the accident here. For the accident, we need to make the report number, date, location, and plate number. So plate number will be repeated here, right? It's going to be taken from the car's table and saved into the accident. Am I right? But this one, because this one is a foreign key, this one is necessary. This one is a necessary duplication of data. We cannot avoid. We should avoid. But it's wrong if you take the model of the car and you save it here into the accident. Then this model is going to be duplicated. So in case you want to modify or to correct any mistake in the model, you have to go to the two places and modify it. This is the very simple scenario. Okay. Also, another thing, it's unnecessary duplication. Why? Because the model number, we can retrieve the model number based on the plate number. So why we should repeat it? So if we repeat this, it's considered as unnecessary duplication of data. Okay. So that's why we, based on the normalization, we are going to avoid the unnecessary duplication of data. This is number one. Then after that, number two, the process of decomposing with anomalies to produce smaller and well-structured relations. Okay, so we need to ensure that our relations doesn't have any anomalies. Later, we will understand what is the anomalies. Okay, you already understand them. I already explained to you these anomalies before, but without the name of anomaly. That's why. Later, when I explain to you, you understand, oh, this one called anomaly. Okay, you will understand it. It's very easy. So here, we make sure that the data, our design doesn't have unnecessary duplication of data, doesn't have any anomalies. Okay? Recap. A definition here. A relation is a named two-dimensional table of data, right? This is the table, right? The table has columns and rows. So not all tables qualified as a relation. Just forget about this. Then the requirements here, we have every relation is unique, has a unique name. Every attribute value is atomic. Every row is unique. Attributes, columns in table have unique names. So we keep in mind all of these things. Okay. After this, we go to the well-structured relations. Okay. A relation that contains minimal data redundancy and allows user to insert, delete, and update rows without causing data inconsistencies. Okay, data inconsistencies happened when we have multiple versions of the same attribute or of the same entity. So in this case, the multiple versions could be the same or could be different. So maybe, let's say we saved the based on this example here. Suppose that the car number 100, plate number 100, had an accident. So we created the report number 1 for that car number 100, and we also saved the model here in the accident. So what if we realized that we did a mistake here in the model value? So we modified this or correct this to be saved in the cars table only, and we forgot that we have another copy in the accident. So in this case, we will have versions of the model, right? So this is what is considered inconsistency. This is only one very simple scenario. Okay. Goal is the goal of the what they call it normalization is to avoid anomalies. The first type of anomalies is what they call it insertion anomaly. Insertion anomaly. The second one is what they call it deletion anomaly, then modification anomaly. Okay. Insertion anomaly is when adding new rows, adding a new row forces user to include the details of that row. Okay, so this anomaly, insertion anomaly, happens when we insert a new row in our table. This is, just keep it in mind now. Later we will take some examples, you will understand very well. Then deletion anomaly, it happens when we delete one or more rows. So it may cause a loss of data that would be needed for other future rows. So if we delete some rows, and based on that deletion, some data is needed in the future is going to be lost. So in this case, our design will cause or will have what they call it deletion anomaly. And then the last one is the modification anomaly. When we change data or changing data in a row forces changing data to another row because of duplication. This is what happened in our scenario. So if let's say the model number of the car is saved here and saved in the accident. So in this case, if let's say we want to modify here, then we need to modify there. Okay. That's all about the definitions of the anomalies. Let us now consider some examples. So here in this slide, we have what they call it employee table. So the employee table have the employee ID, have name, or has name, has department name, salary, course title, date, underscore completed. Question: is this a relation? The answer, yes. Unique rows and no multi-valued attributes. Correct or not? We don't have any multi-valued attributes. Also, every row is unique. Okay, the second question. What is the primary key? The answer is composite here because we have two fields with the underscore, right? The first field is the employee ID and the second field is the course title. So in this case here, the primary key is a composite with primary key of employee ID and course title. Okay, this is based on the slide, based on the example that we have. Okay, I'm not going to go there. Anomalies in this table, they are explaining this here. But I'm going to ask you some questions. If let's say here, what courses do we have here? We have SPSS, we have surveys, we have the tax account, SPSS again, C++, SPSS, Java. Okay, what if there is a student number 200 who wants to take a course of data structure, for example, or let us take a short name, C#. So here, what we need to do is to insert student 200 with his name, his department name, his maybe salary, or this one is employee, not student. And also here we need to insert the course information, right? C#. Then this one will be inserted later after he or she completed the course. So this one is what? This one actually is another entity, right? The employee is one entity and the course is another entity. So when we insert one entity, it enforces us, this is the entity that we inserted. When we insert an entity instance, to the table, it enforces us to insert another entity, which is a course, right? So this one, what they call it, insertion anomaly. This is what they call it, insertion anomaly. So in this case, we should realize that we had something wrong in our design. Why we have something wrong in our design while every row is unique and we have no multi-valued attributes? But one condition that's very, very important, which is never to have more than one entity in the same table. Never have more than one entity in the same table. So here, based on that, we should have 3 tables. One is for the employee, one is for the department, this one is together with the employee, and this one is for course, and this one's supposed to be registration, which involved or connected to the course and the employee. So how many tables here? We should have minimum 4 tables. Minimum 4 tables. Why? The first thing is to avoid the insertion anomaly, which is already happens here. How many types of insertion anomalies here we have? We have the first one with the department, the second one is with the course, and the third one is with the registration. 3 insertion anomalies. So when we insert in an employee, we have to insert information about 3 other entities. Okay, so this is unpreferable, or must be avoided. It's not an optional thing. So your design, if your design has this kind of thing, your design is going to fail sooner or later. Okay, so here, this is the first thing. What is the second problem? The second problem is the deletion anomaly. So if, let's say, we delete this, what will happen here? We will lose the information about the Java, right? We will lose the information about the completion of the course, right? Are you with me, guys, or not?
Yeah.
Is that clear or not clear?
Clear, clear.
Yes. Let's say we delete this, then this guy actually is still here because we have his name in different place, right? So the employee information is not going to be lost, but the course information and the completion of the course is going to be deleted, right? So in future we cannot retrieve this. So this is also wrong design. Okay, so this is what they call it, deletion anomaly. The third one is the modification anomaly. So if, let's say, we realized that this guy, Suzanne, her name is wrong. Maybe she has an E in the Martin, E at the end here. So in this case, we have to go here, modify. Then after that, we have to go here and modify, which is a modification anomaly. Also, if, let's say, the salary of this guy has increased, it become 49,000. So in this case, we have to go here, modify. We have to go here and modify. Okay. Also, if, let's say, the course name is changed, maybe, let's say, this one become SPSS plus, or maybe we realize we have SPSS 1 and 2. So this one is SPSS 2, and this one also is SPSS 2. So we modify twice. If we forget to modify this, then we will have inconsistency of our data, right? So that's why this design is totally wrong. Okay? So this kind of anomalies we have to avoid. How to avoid them? They already explained here. So you can go through. Insertion cannot enter a new employee without having the employee take a course. Okay? So the deletion, if we remove employee 140, we lose information about the existence of a tax accounting class. Okay? accounting class is here, only this employee has taken this. If we delete this employee, then the course is going to be totally deleted, exactly like the Java. Okay? Also, the survey. If we delete this record, the survey is going to be deleted. Then here, modification, giving a salary increase to number 100 forces us to update multiple records. So employee 100, modify the salary, then we have to modify into records or more than one record. If we modify something in two places, that means we have something wrong in our design. Okay? Why do these anomalies exist? This is very important. I have combined two teams, entity types, two entity types or more into one relation. The result results in duplication and an unnecessary dependency between the entities. So here there are very strong dependencies in the course, the employee, which is unnecessary. So every employee is based on, depends on the department and depends on the course. We cannot insert employee without having course, right? Because this one is mandatory. It's a primary key, right? So once we want to add an employee, that employee must have taken a course. Okay? Okay, so here, this results in duplication and unnecessary dependency between the entities. How to avoid them? I don't know why this title. Functional dependency, yeah, we still continuous anomalies. Let me modify it before I forget. Okay. Functional dependency, something called functional dependency, the value of one attribute, like the determinant, determines the value of another attribute. Okay. What is this? What is this? This one actually is when we have this one here. Okay, let me use the annotation tool. Sharing. What happened? Guys, my my desktop is shown to you, right? You can see my slide?
Yes.
Yes,
I don't know why it
Yes.
shows this. Once you start annotation, sharing will resume. Oh. You want to continue? No. Okay, here. Let us forget about it. Oh, paused. Why it's paused? Meeting recording is in progress. I don't know what had been happened. Okay, this one is still recording. Alhamdulillah. Okay, now it works. Okay, now the problem here is that this is based on this and this belongs to the same entity. Okay, so this what they functional dependency. Okay, here instead of allowing these values to be dependent another field or dependent on what they call it part of the primary key. Okay, part of the key, not based on the full fields of the primary key. So this is considered functional dependency. Okay, so this is not a good thing. We have to avoid. Let us continue with the slides and follow. Here we have candidate key. Candidate key actually is a unique identifier. One of the candidate keys will become the primary key. So example, perhaps there is credit card number and SS hash is a table in a table. In this case, both are candidate keys. So we have many things that could be primary key candidates. So because the employee has, for example, what they call it here, credit card number. So in this case, the credit card number is also unique as a primary key. Okay, here that's why this is one wrong thing that shouldn't happen. Also, each non-key field is functionally dependent on a candidate key. Okay, just forget about it. I'm going to explain to you later. I'm going to explain to you when we go through the normalization. In every step, I'm going to explain what kind of anomalies or what kind of wrong design we have to avoid. Okay, let us see the steps of normalization. Step of normalization is 1, 2, 3, 4, 5, 6. Could be 6, could be 8, could be 9, could be 15, could be 2, could be only 1. Okay, it depends on how good is your initial design. If your initial design is very good, excellent, has no problems, then when you apply the normalization, you will find you don't have to do anything because the initial design is from the beginning is solid and excellent. But if let's say your design is not that solid, is not good enough, it still has many problems in the design, then you have to check stage by stage. You have to go first. You take your design, your initial design here. You have to remove the multi-valued attributes. Multi-valued attributes. This is the first thing. This is the first stage. So after you remove the multi-valued attributes from your design actually is going to be in the first normal form. So if your design has no multi-valued attributes, it's going to be in the first normal form. So it will be in this state. Okay, the state in this case is first normal form. Okay, after this, if we also check our design, then we remove partial dependency on the primary key. So in this case, our database or our design will be in the second normal form. After that, we need to remove the transitive dependencies. Transitive. So if we make sure that this one is not here, the transitive dependencies is not in our design. Also, there is no partial dependency. Also, no multi-valued attributes. Then our design is in the third normal form. Okay. All of these states here are cumulative. So our system or our design cannot be in the third normalization form. It still have some multi-valued attributes. So if let's say our design doesn't have multi-valued attributes, but for example, it has multi-valued attributes, doesn't have a partial dependency, doesn't have transitive. Our database still not in the first normal form, still not in the first normal form. We cannot say it's in the third normal form. Just give me 2 minutes. I will check. Somebody is going to cut the electricity. I will check what happened. Just give me 2 minutes.